The Sipoc is the first tool of the DMAC for implementing a project. The columns of this simple list are predefined for specifying suppliers, their inputs, the related process steps, the resulting outputs, and their customer. In my opinion, the Sipoc is rather worthless in itself, but it fulfills important purposes in the tool chain. The first purpose is to determine the significant outputs, which then can be evaluated by the customer and manager in the subsequent voice of customer and voice of business to identify the critical problems. The second purpose is to define the limits of the project, from the last relevant output to the first relevant input, and thus to define the field of the project. And the third purpose is the transparency of the core process steps within this project field. Limiting output should be the output with the chronological last problem from the problem statement in the project definition. The video Cookie du Chef showed that our customers did not like the delivered cookies and the delivery date was too early. During the process steps, the cookies reach higher development stages. These stages can be specified by the modified or added attributes of the cookies. I always specify the output at least by the last attribute added. The output in the last step was the delivered cookie, and I enter cookie delivered and thus name the output and put its latest attribute in brackets behind it. This output is the lower limit of our Sipoc and I enter it in the lower right cell. The first input should be the first possible trigger of the output problem. This limits the project field to the relevant process steps, which include all relevant outputs, their problems, and their possible triggers. Since I don't know if the customer didn't like the cookies because she actually requested a different type of cookie or because the cookies just tasted bad, I enter the request for cookies with their attributes in the upper right cell. Request, cookie type, and delivery date. Now we know the field of the project from the first input on the top left side to the last output on the bottom right side. The next task is to break down the enclosed processes of this field into core process steps line by line in the rows of the Sipoc. Here it is important to find the balance, not to become too detailed as in the later process mapping and not to sketch too roughly. Sigma Guide can take up a maximum of 16 core process steps. Typical in practice, however, are 8 to 12 entries. In the first process step, the request is checked and transformed into an order. This order has the same attributes as the request, and I put them in brackets here as well. Order for cookie type and delivery date. This is our first core process step, input, process, output. Now I determine all intermediate outputs and define their relevance by the fact that they are either significant new outputs or attributes of a preceding output have been transformed significantly. Thereafter, the next output is a shopping list. Then we have the ingredients completed, the workspace clean, the ingredients are weighed, we have the dough as a ball and the dough as a sheet, transformed to the cookies raw, the cookies baked and boxed. Then comes the last output, cookies delivered. To close the gap in the table, I copy this entry, paste it under cookies boxed and delete the last entry. Please never use cut and paste in Sigma Guide. Otherwise, the cell references in the following tools will be wrong. Next, the inputs are specified. We know already the request for cookies. In a consecutive process chain, the output of an upstream process step becomes the input of the downstream step. Here you can see that the next input, the order, is the output of the preceding step. If an output in one step serves as an input in a following step, please always copy the corresponding output and paste it as a new input. In the following tools, inputs and outputs are analyzed separately. Only if identical inputs and outputs match exactly in their spelling, Sigma Guide can make this separation. In the input analysis, for example, the outputs are also listed, but are enclosed in squared brackets. This means that these inputs are also available as outputs and have already been evaluated as output in the preceding tool critical to quality. And that's the way it's supposed to be. A new input are the ingredients as well as the time signal to start baking. In the next steps, we can again copy the outputs as subsequent inputs: the ingredients complete, weight, the dough as a ball, as a sheet, and the raw cookies. A new input is the tin in the next step, and this cell should actually contain tin and cookies baked. This, however, would give us 2 entries later in the input analysis, of which only the new input, the tins, are relevant, because the cookies baked will be evaluated as output in the tool voice to critical. To avoid this redundancy, I will leave it at the new input, tin. The last input is again a previous output, cookies boxed. Now let's enter the activities to the process steps. Describe each process step with a verb and a noun to illustrate the transformation of the input into the output. You probably remember the process problem-solving model. Inputs and outputs are always tangible or intangible objects, such as cookie or date. Process steps are always activities, such as baking or entering. To transform the request into the order, it is necessary to check the disposability of cookie type and delivery date. To transform a dough ball into a dough sheet, it is necessary to roll out the dough. At least the suppliers of the inputs are entered and the customer of the outputs. Now we have divided the entire project field into the core process steps and can very easily track the development stages of the cookies based on their intermediate outputs and attributes. At least please check the consistency of all core process steps. If your Sipoc now matches reality, then you can copy it into your project storybook.